As usual, I'm here with a cup of coffee, part of a script in front of me, and a camera running to attempt to record yet another YouTube video. As I'm discovering, I just kind of need to say what I'm thinking in these and edit it later, even though I don't like editing. But what am I here to talk about? This little thing. Let's see if I can get a. What is it? As I've been building these videos, one of the things that I've noticed is I don't like editing. So any chance I get to where I can pre-film, I guess you should say, the cuts ahead of time and put that into the main footage, then I don't have to do as many edits later. Especially if I'm running 3 or 4 cameras like I am here, where I switch between this camera, the overhead to show something, and another camera, and other video sources coming inbound. I use OBS, and I guess this kind of applies for streaming too, but in my case, it's really just recording. But I use OBS, and inside of there, you can assign keyboard macros to do certain things. If you want to change scenes, if you want to apply filters, if you want to have text, kick text scrolling across, launch a video, share your screen, all those sorts of things, you can pre-program keyboard combinations. So I started doing that at first, and I immediately forgot what all the keyboard combinations were. I wrote a little post-it note, set it down there, completely didn't do it, ignored it. Didn't work for me. So then I thought, it's because there's multiple keys, so you end up with this weird, Control-Alt-Shift-5 to be scene 5 or something. So I went and Googled, and I came up with people who said use a second keyboard. So I've got a little Raspberry Pi keyboard. I should show a picture of a Raspberry Pi keyboard here, or mine if I can grab it and find it. And I thought, it's small. I'll set it on the side over here. I'll plug it in, and then I'll use that keyboard as the HID input for the shortcuts. The idea here is you've got multiple HID inputs coming into the computer, in my case a Mac, and what you do then is you select which keyboard is the one you're going to receive inputs from, because you have multiple keyboards, including your main one that's sitting here. So what you do is, let's say I want to have the A key on that little Raspberry Pi keyboard switch something, or number 1 be scene 1 on that. So you go up, and there's a plug-in and some other stuff for OBS that you can use to do this with, and then you press that button and away it goes. What I noticed was the plug-in wasn't easy to use. You had to muck around with XML files. If somebody knows an easier way to do that, I would love to know. But HID inputs are kind of the way most people do that side of the house. I thought, well, let's find another way to do this. I went digging around, and I've been meaning to play with MIDI on Arduino microcontrollers. I've got a couple of other projects that I'd really like to mess with MIDI. I'd love to have an Arduino be the source of a synthesizer sound, or being able to play synth sounds, like play a MIDI file back, or turn one into an actual MIDI sound system, like an MT32 or something like that. So I went digging around. A couple things turns out. One, there are some Arduinos out there that do MIDI. Not a ton, but the Arduino Pro Micro. There's various is it High Let Go, and a couple of others, and I'm pretty sure Adafruit has one or two even. In fact, the Adafruit articles are kind of the ones that I found when you're talking about MIDI and an Arduino, and it looks like they are either the author of or one of the contributors to the USB MIDI project that I'm using for this. So I thought, okay, cool. How do I get MIDI into OBS? Okay, so again, Google around. I find a couple of MIDI plugins that allow you to map MIDI inbound commands to macros or things that'll happen inside of OBS. Cool. All right, so I downloaded one of them, and I think the first one I tried was OBS MIDI or something like that. Turns out it hasn't been touched in 2 years. It works on Windows, they claim, but will not work on a Mac. So dump that. It wasn't that quick. I actually installed it, tried it, troubleshoot it, and had to figure out, hey, this doesn't work. So don't use that one. I'll try and remember to include the link to the one that didn't work. So the other one I came across was OBS MIDI M, as in Mary, G. So Mike Golf. And that one has turned out to work okay. plug in, put it in. You can set up the keyboard. I'm sorry, not keyboard. You can set up the macros. And on a MIDI message coming inbound, you can do things. So in my case, let's pretend there's no Arduino here. Let's say you take a MIDI keyboard, you set it down, you plug it into your computer. It appears as a MIDI device. You could map like middle C to something up in that plug-in. You could use like a regular keyboard to do this. And I've seen people use MIDI controllers like the Akai and some others to do the same thing with. So you could do that, which by the way, this would work that way. You could modify it. In my case, I just wanted a little thing, basically a little remote control. I could just sit here and I could push buttons on and change stuff and away we go. And I wanted it to be really simple. So that's what this is. It's super, super simple from an electronics perspective. I'm only recently have dug back into electronics, recently being like 5 years ago. But I'm experimenting more and more with electronics and trying to integrate them in DIY and make some of my own things. This is a from scratch, like out of my brain sort of project with a lot of help from the internet. But the idea is, right now I've got 8 buttons on here, little momentary push buttons. And if you notice, there's no other hardware on here. There's no resistors or capacitors. It's just the Arduino and 8 buttons. I'm using the internal pull-up resistors on the Arduino, so I don't need anything on the hardware side. Now, everybody can talk about pros and cons, and I'm doing debounce in software inside of here. So in the future, there'll be a mod that can go onto this to actually do a little more on the hardware side. But in keeping with super freaking simple, this is all it is. Total cost is about, I would say you could build this whole thing for under 20 bucks. Probably more like 15. It's not a whole lot. Problem is you got to buy like 100 buttons and you got to buy like 3 Arduinos, that sort of thing. And you can get all this off Amazon. And I should mention, I do have a GitHub project that I started for this, and the code is in there, as is a design, and there's sort of an accompanying GitHub Pages site that has the same information in it that I'll link to in this video, and that will link to this video. So, back and forth. So that's the hardware. Super basic. Arduino Pro Micro, 8 little buttons, you're done. Now, on the software side, I like VS Code, Visual Studio Code. I shouldn't say like. I mean, I like it, but I came up in a world where you just use text editors to write code. I didn't come up in the age of IDEs. When I was in the Unix world, I remember Sun came out with an IDE in the mid-90s, and nobody really used it. We used VI and type make. And that was our entire development world. But nowadays, with the complexity of code and some of the tooling, VS Code, I really do prefer as an overall project to use for a project. Inside of that, when I do microcontroller development, I've come to like Platform I/O. You could use the Arduino IDE for this, and I mentioned that in the page that it probably should work, but I can't guarantee. I haven't tested it. So this is Mac OS. It's current as of 2022, late 2022, with current VS Code and current Platform I/O. It includes a USB MIDI library that you add into the library and include a .h file. And then you just map the physical pins, whatever the pin numbers are on the Arduino, to the corresponding MIDI note number that you want to send up with that. So in the code, basically what it does is it just takes the button, and since there's internal pull-ups done, it just, when you push the button, it drops it low. I debounce in software, like I mentioned. Future mod, I'm hoping I'll just use an RC circuit to help debounce on each switch. I'll figure that out later. Which, by the way, I'm already thinking about future stuff, which we'll get to here in a second. And Platform I/O is the tool that you can build it with. Right now, go in there, pull down the code, hit build, hit deploy, boom, away it goes, and you start pushing buttons. You can tweak and tune that as you want. It's super bare bones code. I'm going to have to work on it. It feels like I wrote it when I was like 11 years old. There's no fours. It's really ugly code. When you see it, you'll understand. Like, I haven't touched C, C++ in 20 years. And it really, really shows. Oh, mods. Future direction. I ended up calling this the MIDI deck, which it really is at its core. It's like a Stream Deck that, you can push buttons and do things with on a computer with OBS or whatever at its core, but it's really, I'm only using it for OBS, so I'm calling it the OBS remote. The additions I'd like to add. So first off, I'd like to have a mod. And I'll say, if any of you remember back in the early days of computing, let's take like the Atari 800s, the Tandys, the TRS-80s, the Commodores, right? In those sorts of days, you could get what we called mods, modifications or hacks, whatever you want to call them, that would alter the way the hardware worked. You kind of viewed your computer out of the box back then as the basic starting point. It wasn't the end result. So you'd, in most cases, go into BBS and, find somebody who had a schematic in ASCII and a description of a mod, and you go to Radio Shack, get the parts, and, go home and hack your computer. That's the way it used to be. So I'm kind of taking that same approach with this. Here's your out-of-the-box computer, right? Here's your TRS-80 kind of thing. And then you can mod it as you want. So one mod is going to be hardware debounce. Have to figure out how to do it on the hardware side with, there's going to have to be 8 of them, right? Or more. I'm doing 8 buttons right now, but you could do more buttons. I think you're limited to 12 with this Arduino. But that's mod. Well, this is the Mark 1, and we'll call that mod A. So the other one, today this requires a USB cord plugged into your computer, and I don't want that. I want it to be an actual push button, like a remote. So immediately I'm thinking, how can I put a LiPo battery on here with a charge recharge circuit, and at the same time do something like Wi-Fi? Well, I'm sure the Arduino can do Wi-Fi. Question is how to send the MIDI messages. Turns out RTP MIDI is a thing. You can send MIDI messages over a network. It is built into Mac OS, and there's essentially a driver, an application that's open source, I believe, for Windows, to allow you to basically what they call peer this with the computer. Imagine it's kind of like Bluetooth, but over Wi-Fi. Same kind of idea. And then this, in theory, could just send the message over the network, Wi-Fi, and have it on a LiPo battery, put it to sleep in between, have a power button and some other stuff. But that's one I'd like to do. I think that's actually 2 mods. So I think one of those mods is being able to do RTP MIDI, and the other mod is taking this actual, like on a battery, unplugging the cable. They kind of go hand in hand, but we'll treat them as 2 mods. So hardware debounce mod A, doing RTP MIDI over Wi-Fi, call that mod B, and mod C would be taking it onto a battery, making it truly wireless, right, without wire. And I think that's about it. So in the next little bits, I will go through the hardware, how it's built, how it's put together, and I will go through the software and how to do it. And then I think that's about it, and you're on your own then. Oh, I should mention there's kind of a final version of this that I've made. I'll show a picture of it here, but let me actually grab it, unplug it. I got one of these nice little boards. It's an Adafruit. It's actually it's a PCB that is was it a half of a full-size 830 breadboard. They're nice. I'm really liking them, but they're like $5 each. But it's a nice proto board. So what I did was I did the same thing here, and it's so there's the Arduino on there. And I put 8 push buttons with their little tops on them and wired the back, and that's all there is to it. 3D case would be neat to do. So what I have set up is the top 4 are scenes, and then the red is start recording, white is stop, and then the 2 bottom ones are my 2 desktop screens to share. I'll just show you what it looks like right now. Let's plug that one back in. And right now I am on input 3 or 4. I need to number them or something. So there's 4. Let's go back to my overhead camera. Number 1. Let's go to my front camera. Right there it is. That's my iPad in front. Here's my overhead plus that. So it's basically scene 1, scene 2, scene 3, scene 4. And there we go. And you can set this anywhere, but I want it wireless. So I'll tell you kind of a little bit about how I built it. Enjoy. got some coffee and the prototype board here, and I'm kind of going to go through what it actually is. As I said, the basic idea is to push buttons to have things happen on the computer in applications like OBS Studio, which is my particular use case right now. The Arduino Pro Micro microcontroller here, kind of two words there, the microcontroller. Like, Pro Micro is not the greatest name to use in here because it's a microcontroller. Anyways, there's the microcontroller, and it's really just 8 buttons. So what I did, and technically I don't need this red power jumper because I'm not using any power. What I'm doing is using the internal pull-up resistors on the pins that's inside the Arduino, which in the code you'll be able to see. And then I'm just taking the ground through each one and bringing it back into a pin on the Arduino to pull low. So when I push a button, it'll pull that pin low, which then I can latch onto and do something. In this case, I'm going to send a MIDI message up to the host. Real simple little device. Ultimately, this could really be pared down into something smaller. I think ultimately I'd like this to be, I'm going to call it an OBS remote. I think it could also work over Wi-Fi with MIDI on here on the chip. RTP MIDI is a possibility. I don't know if it'll work on the chip, but in theory, this could go Wi-Fi and then do RTP MIDI. I suppose the other option is Bluetooth. I don't know if this does it. I hadn't planned on any of this, but it would be nice to get rid of this connecting cable. So here's my idea. RTP MIDI, put a power button on it, and a LiPo battery with a LiPo charging circuit. So you can plug it in, charge it, and then take it off, power it on, and use this as a remote control in your hand. Just, push the button, whatever they are. Now, again, this is prototype, so the buttons are just little micro pushes. Eventually, the idea is I'll design some type of little 3D case or something, but for now, I can just push these buttons and use them as is, and it works. But again, super simple, 8 buttons and the Arduino Pro Micro microcontroller and some wires. I think grand total cost of this right here, maybe $15, somewhere in that range. You can pick up the Arduino Pros off of Amazon. I think I paid $16 for the 3 of them. You can see my tests up here that I was working with before. Nice little chip. I really like this little chip. It has the MIDI capability built into it. Haven't figured out how to change the MIDI device string, which I'll show you what it looks like on the host site here pretty soon. And then I haven't figured that part out. I'm using Platform.io, PIO, Platform.io, whichever way you want to call it, and using the MIDI USB, or I can't remember, USB MIDI. It'll be on the website, the MIDI library that goes with it. And it just sends the MIDI messages over the USB cable up to the host, and away you go. More of that to come. I'll describe that in the software side, and I'll also describe the MIDI parts and kind of how that works. And I'll put links. There will be links for all the other software that I'm referencing and I'm using, like that particular library and some other ones. But that is the hardware right there. I have some other parts on the way. I'm going to actually solder this reel onto a board and try and make it look a little bit better as the version 0.1. But there is the breadboard version. And here's how it works. So right now in my OBS, I have this particular camera view set on number 3. So if I push button, oh, by the way, buttons are numbered 1, 2, 3, 4, 5, 6, 7, 8. I think there's room for a couple more buttons, but I only need 8 right now. So top 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. So right now I am on number 3, which is a scene. And inside of OBS, I have a scene change mapped to each of these buttons on that MIDI command. And I have them mapped right now to send up MIDI. They're note on messages that I'm sending up. I'm not sending note off messages. Turns out you don't need them. But the note on numbers are like 50, 52, 54, 56. So it's middle C, and then you kind of go up to D, E, F, G, A, B, C. So if you were to actually push these on a piano, if you had you could do this if you had a MIDI keyboard hooked up to your computer. You could just, hit middle C button. So actually, by pushing this, It's like pushing middle C is the exact same idea. Anyway, so right here I've got that mapped to number 3. So now I could switch over to my iPad on the other scene, which, as you can see right here, now it's switched over. If I'm going to go to my overhead up above, push button number 1, and now I'm to my overhead. Go back to my other camera, and there we go. I also have start and stop recording mapped to these two, which I probably should put them on the other side because they're too easy to hit. And then I've got some screen share stuff set over here, so I can go to one screen, or you can go into the infinite loop screen. And you can see here where I have my scene set up on this particular screen right down here. I'm going to go over the software side of this a little bit. So amazingly, I actually just used this little device to start this recording and to change to this scene, so it's already paying off. What I did was I'm using VS Code. Let me add, you could use something like the Arduino IDE for this. It is entirely possible. You could take the stuff out and use that. It will work. I personally sort of, grew up above it and got beyond it pretty quickly. So I switched over or back to VS Code from Microsoft, and I actually like VS Code. On top of that, I'm using Platform IO. I guess from here on out, I'll kind of call it PIO because that's what it's listed as in many places. But Platform IO, PIO, brings IoT development into VS Code and makes it super easy to do more advanced programming on microcontrollers. And I say more advanced because it does bring some weight with it and some heft and a learning curve. So if you just want to jump in, I will be providing a firmware file that you could, in theory, just burn with all of my pre-programmed stuff and use it as is, as long as you set up your OBS the same way I did. In theory, you could do that, or you could pull it up. This is on GitHub. I will show that on GitHub. So the code is up here on MIDI deck. That's what I'm calling it for now. I might rename it to OBS remote since it's really just an OBS, but for now it's MIDI deck. And it's broken down. It is a VS Code project, and there's some Platform IO stuff up here to make it work. But basically, docs, here is where documentation's at, which I need to work on docs. It is a GitHub Pages site, and the MIDI deck code is inside of here for VS Code. Here is fritzing. I am including, I'll have to show the image of this. Here I am including a breadboard picture you probably saw on the site or in the initial part here. I had to cut a picture in here of that so you can see what it looks like. It's available too to help you actually wire it up. And then in MIDI deck, here is the code. The main code is main.cpp. And then you have to add a board. So inside of Platform IO, what I've done was if we pull up PIO and look at libraries, I went inside of here and I added, where does it show it? Right there. So right now I am using, come on, I think it's USB MIDI or, yeah, MIDI USB. That's my old project. Here's this current one right here. So MIDI USB is the library, and that is stamped inside of a Platform IO configuration file then. If we look at platformio.ini, here's where we're telling it to do that and which framework to compile with the board. This board shows up as a Leonardo. I understand they're very similar, probably the same thing. This is just a different profile board, but it shows up that way. So if we get down to the basics of it and we look at main.cpp, by the way, my C++ programming is 20 years old at this point. I am going to work on this quite a bit and refine this code and definitely refactor it down. Right now, it looks like I wrote it like in when I was like 12 years old. There's no variables. There's nothing defined. It's just all simple. Like I hard coded everything in here just to get it working. But anyways, standard Arduino include the things we need. I don't think we actually need pitch to note. Maybe But it was there in the example. So here are your pin mappings. And those are the buttons, and as I mentioned, it's top row are buttons 1, 2, 3, 4, bottom row are buttons 5, 6, 7, 8. And if we look on the picture, that are these pins down here I'm using the outer 4. So we've got those 4 and those 4. That is the top row and that is the bottom row, and there's the pin numbers. So in the code, they are mapped out as those are the physical pins on the Arduino. Some state tracking. There's some functions here. Note off is not used, neither is control change, but I keep them in there right now because I might use them in the future, either in this code or other code. Technically right now you don't need those, so you could clean this up for debugging. And notice right here, as I say in the hardware, it's a pull-up. You don't need resistors on the board, using the internal pull-ups for all the buttons, which is really helpful. And here it is, the digital read in the main loop. So all we do is when it comes inbound, we can change this delay 500 to more like 100, I think. I thought I did. Yeah, we'll change it to 100 because you don't need much. That's really to get around the debouncing. That is a primitive debounce. I suppose hardware we could debounce it some other way with like an RC circuit, or I could use 555 or something, but this is easy right now. Yeah, I had disabled the note off. I don't know why it came back. We'll have to fix that. So by the time this goes out, the note off will be gone and the delay is going to be 100 milliseconds. And that's all it is for the code side. So all you really have to do, if you use my pinouts, just leave those alone or change those if you need up there for the actual pins. This is really all you'd have to change. The other one is I hard-coded the note messages that are being sent. So I'm sending middle C. Oh, wow, I need to clear out my comments. That is a middle D, middle E, F, G, so on and so forth. It's like, I think this is C2 on the keyboard. Maybe, yeah, I think it's C2 or C3, probably C2, but middle C. They're hard-coded right now. Again, my C++ coding is really rough, so I plan on getting back and setting all of these as defines and variables up front. So it'll be much easier to code, and then this will just become a for loop and, loop through the state based on an index number of an array for the button. All this stuff will get refactored down into a lot tighter of a code. But in the spirit of the name of the channel, this is technically working, so boom, I can release it. I'm going to walk through how to troubleshoot after you get the code uploaded to the Arduino. And I'm going to add, I am on a Mac here, so this is all going to be done from that perspective. I'll try and throw in what I know about Windows, but I hate to say you're kind of on your own there. So on the Mac, I'm going to pull up the audio MIDI setup option first and go to the MIDI studio. In theory, at this point, if you sent a message successfully, at least this is from what I can tell, a message comes through, Mac OS detects it, and adds this interface inside of here. So it is now in. This is your first step to understand that you're actually getting communications coming in from the Arduino outside. You can go in, and here you can change the name. I'm not sure how much this reflects around in other things, but eventually I like to change the name inside of the device itself. You can add, a little icon or other stuff, but generally here is step number 1, the audio MIDI setup. On Windows, I think it would depend on how you're doing your MIDI, but I honestly can't say. If somebody can describe that process in a comment, that would be quite helpful. So once that's set up, to actually see if you get something coming in on the Mac, I have found this MIDI monitor to be quite helpful. Download this, install it. I'm pretty sure it comes down as a Mac PKG file, and you just install it. On Windows, when I was trying it, I was using this freebie to see how it works. It looks like it's actually available for a Mac, so Maybe I should try it down here too to see how it works. Once you get that installed, bring up the MIDI monitor. And when I push a button, I'm actually recording this in OBS right now, so when I push the button, it's going to be for this particular source that I have selected that's sharing this desktop, so it doesn't change. And there it comes in. Now notice I got 2, so the debounce, you can tell, needs some work on that. Plan is to have a hardware debounce mod in the future. If you modified that timeout value, you could avoid that. Not to mention, here's the other issues. Little buttons that I have on this particular device, they're 9 millimeters tall, and I've noticed the taller ones have a larger tendency to bounce because they kind of move around a little bit. If I had a case and that was secured in a little hole, so you only had a little tiny bit to touch, it probably wouldn't be as bad. Though, if we think about what this device does in this particular use case, I am just telling OBS to change something or do something. And since I'm just changing scenes, it doesn't matter. If it gets 2 messages to change scene, it's just going to change to the scene that I wanted it to anyway. So it really doesn't matter in my particular use case. If you had some other automation being triggered, I could see multiples being a problem. I can't think of one off the top of my head, but my current failure of imagination probably isn't accounting for something. But at the end, you notice here we got the correct data coming inbound with the velocity and the note on. Note, I'm not setting the note off here. And if I push it again, there I got one, right? So if you push it real quick, there, I got one at a time. Really quick. But that's how I tested on Mac OS. On Windows is a very similar sort of thing. So I'm going to switch over using my handy little OBS remote to the screen. So watch out for the infinity view. Here is my OBS setup. And inside of the docs, and I'll put it actually on the blog post for this in the docs, OBS MIDI MG is what I am using to intercept the MIDI messages coming in from the device. There was an OBS MIDI plugin, but it does not work with Mac. If you can make that one work, you can use it on Windows, go for it. But what I'm setting up here is using OBS MIDI MG, which from what I've seen is actually a little bit better than the other one that currently doesn't work on Mac. And it almost looks like the other one, they say they were rewriting it, and that was like 2 years ago. So I wonder if it's all but abandoned at this point. But the configuration is inside here in this setup. So what I went in, I first did was I just set up all 8 buttons and call them button 1, 2, 3, 4, 5, 6, 7, 8. And then what you do is you come in on the button and you hit listen once, and it essentially becomes a little MIDI sniffer at that point. You push the button and it'll capture the channel and the note number. It'll also capture the velocity, which we are sending, which I don't think I need to for this, but I'm saying any velocity coming inbound on note number 48, channel 1. You could also manually set this up. And then you come down here and say switch scenes to whatever it is. So then I go through and note the note number changes from the device. And that is all there is to it. We will go back to OBS here. And here's that screen. So when I'm inside of here, I can now just push the button and these scenes will just go. I'll pull that up one more time and let's go tools. Yeah, I should export these. This is a nifty little thing. I'm really kind of impressed with this. And you can see all the way through. I will add, you can do all sorts of automation with these. There's a bunch of things you could do here. Like tons. I mean, you could actually do like repass MIDI messages through, which is kind of cool. Start, stop, man, there's just not. Man, I'm sure if you put more buttons on, you could figure it out. This is definitely a very bare bones device, which was my objective to start with. And at this point, I'm I think I've met the objective, and we will call it technically working. If you have questions, find me on YouTube or, well, I should probably set up something else like Twitter, even though I just like Twitter quite a bit. But I'm available on here or GitHub. I will include links to the GitHub. And if you like this sort of stuff, come back for more. Hopefully I'll be cranking out a little bit here and there. Alrighty, take care.